Let's say that you have a beaker with your favorite weak acid in it. Whenever I talk about weak acid, I usually choose HA to be my favorite culprit. And let's say you've got a bunch of these little suckers in here, and some of them are split and some of them are not, as usual weak acids do. You could do an old-fashioned ice table with these, writing a reaction. And using our model to figure out a K value. See, I must have started with 4 of these because one of them split. Subtract one of these. Started with none of these suckers. Add one of these, add one of those. Equilibrium concentrations, where our K value is equal to our hydrogen concentration times our anion concentration divided by the acid concentration. We'd end up with something silly like 1 squared over 3, or simplified to 1/3. Yay, cool, we have a weak acid. But what if we take our same container that contained our weak acid, and we didn't just put the weak acid in there? What if we also added a bunch of salts like sodium of the weak acid? Now at first this seems a little confusing. Well, why would I do that? How would that affect my equilibrium? Well, let's think about it. When we have a sodium compound dissolving in water, all sodium type compounds are soluble. So we would see that this guy would break into sodium ions that are aqueous and our anion. That's weird. In our original equation, we had our weak acid dissociating into H plus and A minus. So now, instead of starting with just 4 of these guys and 0 of everybody else, I now have additional A minuses plugged in here. And according to Le Chatelier's principle, if I add more and more of these guys, I'm going to shift my equilibrium to the left, or I'm going to resist creating H pluses and A minuses. This is called the common ion effect. And that's when you add a salt, which is just one piece of your acid plus a counter ion that doesn't do anything, like sodium or potassium. And that common ion helps resist the HA breaking apart into H plus and A minus. So in these problems, we're going to end up with a lot higher pH, or rather, we're going to have a smaller concentration of H plus produced than we would before, because that anion will help resist changes in that H plus.